A z-score, or standardized value, is the number of standard deviations that a given value x is above or below the mean. The z-score is calculated by using one of the following formulas, which they essentially are the same thing, except one is used for a sample and one is used for a population, but both say the same thing. Z is equal to x minus the mean divided by the standard deviation, and z is equal to x minus the mean divided by the standard deviation. The difference is just one's sample and one's population. The notation is the only real difference. So if you can write the wrong notation, you'll still get the exact same answer. Though when you are computing the z-score, make sure that you round your final answer to 2 decimal places. Typically, z-scores are always at most 2 decimals deep. So let's start off with this. Eruptions of the Old Faithful geyser have a duration time with a mean of 245 seconds and a standard deviation of 36.4 seconds. What would the z-score be for an eruption of 150 seconds? So I'm going to use a population notation, but again, if you use the sample notation, it's not wrong. It all comes out the same. So I'm going to say that the mean is equal to 245 with a standard deviation of 36.4. Now when calculating z-scores, the mean and standard deviation should not change from part to part. This should always be the same throughout an entire question. The only thing that should change is x. In this case, x is our specific value that we're looking for, which is 150. So what's the z-score? Just plug in our mu, sigma, and x into our formula, and we'll get the z-score. So z equals 150 minus 245 divided by 36.4. And from here, you just do the arithmetic. So when you do this and round it, you're going to end up getting negative 2.61. And that would be your z-score. And if you're doing this in the calculator, make sure to do the top first and then divide that result by the bottom. If you try and put this whole thing in, you might run into an error. So be careful when typing this into a calculator. So what would the z-score be for an eruption of 270 seconds? So again, our mean and standard deviation will not change, only our x value. So x in this case, 270. So z equals 270 minus 245 divided by 36.4. And again, do the arithmetic, plug it in a calculator, you're going to get a z-score of 0.69. Again, be careful when typing it in. Just the top, get an answer, then the bottom, unless you're using parentheses. Just be careful. So last, between what two values will we consider an eruption time usual? So remember, usual is within 2 standard deviations of the mean, 2 down and 2 up. So let's find out the minimum value. So we know it to be 2 standard deviations down, our z-score would be -2. So we're going to say -2 equals x minus our mean, which is 245, over 36.4. And now here's where we're going to do some algebra. So we're going to multiply the 36.4 over. So when we do that, we're going to get -2 times 36.4. And we will get 2 times 36.4 negative 72.8 equals x minus 245. And then we're just going to add 245 over. So plus 245 is going to give us, I'll move this over here for space. We're going to get 172.2 is x. So the minimum usual value would be 172.2 seconds for x. Now the max, we're going to do the exact same thing, except instead of -2, we're going to do +2. So 2 equals x minus 245 over 36.4. So just like before, I'm going to take the 36.4 and I'm going to multiply it over here with 2, which is going to give me 72.8 equals x minus 245. And then just like before, I'm going to add 245 over to 72.8. So move this over here. And when I do that, I'm going to get 317.8 equals x. So my highest usual time could be 317.8 seconds. So what two values would be considered usual? Anything between 172.2 and 317.8.